In this video, I would like to give a small introduction about modern physics. In 1900, Max Planck suggested that light is not a continuous particle, it is discrete particle. That means light can be expressed as integral multiple of some bundle of energy h nu. So mathematically, the energy of light is expressed as E is equal to n into h nu. That is, it is an integral multiple of h nu, where h is called Planck's constant and its value is given by 6.626 into 10 raised to minus 34 joule second. During that period, we have only classical mechanics. According to classical mechanics or our Newtonian mechanics, energies are continuous. So a new branch of physics was born that is called quantum mechanics. In quantum mechanics, all physical phenomena are explained at microscopic level, that is in atomic and subatomic scale. But in classical mechanics, all these physical phenomena are in ordinary scale or macroscopic level. That is the main difference between classical mechanics and our new quantum mechanics. Again, come back to light. According to Maxwell, light is an electromagnetic radiation. Electromagnetic radiation means it consists of electric and magnetic vector which are oscillating perpendicular to each other and also perpendicular to the direction of propagation of this wave. Electromagnetic radiation have many properties. Some of them are, first one is electromagnetic radiation can travel through empty space. That is, for propagation of this wave, no medium is required. Next one is its velocity. Its velocity is given by c is equal to 1 divided by root of mu 0 epsilon 0, and that is equal to 3 into 10 raised to 8 meter per second. That is, they travel with a constant velocity that is equal to 3 into 10 raised to 8 meter per second. And the third property is they obey superposition principle. So we know superposition principle. According to superposition principle, when two or more waves travel through a medium, they can superimpose and a resultant wave is formed. And the amplitude of these resultant wave is vector sum of the amplitude of individual wave. So let us consider two waves. First one have amplitude A1 and second one have amplitude A2. According to superposition principle, the resultant amplitude is the vector sum of these two amplitude, that is A1 plus A2. And the next property is interference. It is a phenomenon of mixing of two or more waves. As a result of this mixing, a new wave is formed with change in amplitude, and this phenomenon is called interference. If the resultant wave have greater amplitude, then it is called constructive interference, and the condition for constructive interference is these two waves should be in phase. That is, here crest and trough will superimpose and you will get a new wave with high amplitude. And this point also appears to be a bright spot. If the resultant wave have lesser amplitude than that of either of individual waves, then such interference is called destructive interference. And the condition for destructive interference is waves should be out of phase. That is, they have a minimum 180 phase shift. So here crest and trough are interfere and you will get a point of minimum intensity, that is a dark spot. So these are about interference. Now we can again go to the electromagnetic waves. The light is only an example of electromagnetic waves. We have so many electromagnetic waves with range of frequency. If we arrange all these electromagnetic waves with increasing wavelength or decrease in frequency, So that arrangement is called electromagnetic spectrum. Table shows electromagnetic spectrum. For gamma rays, we have minimum wavelength. If we go to X-ray, ultraviolet, visible, infrared, microwave, radio waves, so its wavelength increases and its frequency decreases.